because I know a few of you guys like just get off work and just come straight here. I'm considering trying to work it so I can stop class a little bit early, like 10 or 15 minutes early, and then that time will be for whoever wants to just do homework or have questions, right? I mean, this is kind of a looser class. I've got more time to live with an idea than normal because we've taken a lot out from the regular pre-calc. So, I mean, I need you to understand, if you have a question, you can ask it whenever the hell, right? I try to tell students this, that part of my job is to pace the class. It's not your job to pace it. So don't sit there and go, I'm not going to ask this question because I'll slow them down. Ask the question. It's my job to figure out if it's going to slow them down. Does that make sense? Okay. So anytime you have a question about anything math related, ask away. Just don't ask Google right now. It's a bad time. Okay. And the homework, so when is it late? When is homework late?
After the test?
Yes, if you try to turn it in after the test. So you have until the day of the test. But you want to get feedback from me earlier than that, just to make sure that you're doing it in the right format and whatever. Yes? All of us teachers, we have our own little idiosyncrasies, and I try to be very open with what I accept. But basically, do you remember the shirt I was wearing yesterday? It was very welcoming. It said, show your work. You must show your work. Yes? That is the one thing I require from you. There will be times when work doesn't make sense. But when in doubt, show more work. Okay. So let's do this. Does anyone have any questions right now from the factoring homework or from the function homework stuff? No? Okay.
I have a question about the piece.
I had a feeling you did.
Piecewise?
Piecewise? Piecewise? Okay.
Yeah, pairwise. Yeah, exactly.
All the functions delivered.
So for the piecewise,
Yes.
it's called up because of like the different pieces, or does that mean like something else? I guess I don't understand it conceptually, like why it's called that, and like
Oh!
what is the piecewise? Like, is it the entire, all of the information that comes with it, or like a certain, like just the X part with like the confines, or?
Alright, the second part you're gonna have to say again. The first part is, it literally is because of the fact that it's defined in pieces.
Okay.
I could make something about the Y's thing, I could make something up, but I forget why we have the Y's. I feel like it's like if somebody says, what do you think about this money-wise? What do you think about this in terms of this, right? So in terms of pieces is how we've defined it. I kind of made it up, but it does make sense.
Yeah.
But the piece part is because it is in pieces.
Okay, so the piecewise function, that's like the entire thing, like f of x equals.
Yes, it is one function, but at certain points it just suddenly changes definition. But you would do one graph. Does that make sense? And sometimes it actually makes physical sense. I had this thing, it hit something so it just changes trajectory. But the whole teleportation thing only makes sense kind of mathematically, right? It's hard to come up with a physical interpretation. Yeah.
Is there like a limit to how many there are?
How many pieces?
Yeah.
Nope. You can have an infinite number of pieces.
Okay.
In fact, there's a function called the step function, and it, all right, I won't get into the whole thing, but from 0 to 1, it's at 0, and then from 1 to 2, it's at 1. You guys kind of with me? And then it steps up, and then from 2 to 3, it's at 2, and it just does that forever. So math people thought, looks like steps. Let's call it the step function. So that's exactly how we sounded when we did it. Does that make sense? So it could have an infinite number of pieces. Will they show up in will they show up in calculus? Yes, they will. Will they show up a lot? No. But then when they do, I want you to not be freaked out when you see it. Yeah. Anything else from anything specific or just general? Okay, all right. So let's do this. Let me talk for a bit, and then thank God I have stuff for you to work on. So I can also be quiet for a bit. But first I want to show you some kick-ass cool shit. Let's see, if you guys agree, fantastic. If you disagree, everybody's got the right to be wrong. So I'm gonna show you something really, really simple, but I'm gonna show you a way to see it visually. So let me just ask this really silly question. what happens when you multiply 1 by negative 1? The answer is negative 1, correct? If I multiply 3 by negative 1, it's ground shaking. What if I multiply negative 5 by negative 1?
5.
All right, so y'all are cool with that, right? You remember when you had to learn it, two negatives cancel when you multiply. It's like, I always think about negative means turn around, so if you ask me to turn around again, I'm facing the same way I was originally, that's why they cancel. You guys kind of with me? The whole turn around thing, I need you to understand, what I'm about to do is to show you the physical truth that we just never tell students for some reason. Yes? Okay. That almost feels like you're going to be hunted by this. I heard you heard that thing. We have to get you. But no. So here, everybody do this with me. Number line. 0, negative 1, 1. There we go. So I'm going to show you the visualization of what you're doing. If I start at 1 and I multiply by negative 1, do you see how I make a half turn? You guys see that? Does anyone know how many degrees that is? 180. To push my luck, does anyone know how many radians that is? Okay, good. Well, it's a trig related thing, and trig is going to be a part of our class. We'll get there. So let's stick with degrees. Is everybody cool with that? Has anyone ever heard of it described like that? But you can see visually that's what happened. If I multiply 1 times negative 1, I make a half rotation, yes? What if I multiply negative 1 by negative 1? Where do I go? You kind of do the full circle now, yes? And that's why I get this, what's negative 1 to the first power? Holy shit. What's negative 1 squared? 1. What's negative 1 to the third power? Oh, sorry, go ahead.
Negative 1 to the first power is 1?
No, it's negative 1. Negative 1 to the first power is negative 1.
Right. Yep.
Because first power, of course, leaves it alone.
Yep.
Negative 1 squared, the negative cancels, yes? Negative 1 cubed is basically negative 1 squared times another negative 1. Are you guys all? And now you can see it's just go here, go there, go here, go. You guys kind of with me? So this visualization of this, on the surface, it almost seems, you don't need this, right? You're like, that would have been nice if they would have shown me that way a long time ago. But I don't need it now, math boy. I'm okay. Yes? So here's what's really cool. Can you guys tell me, when I'm talking about multiplication, I basically gave it away up here. Where do I put a number to represent a certain number of multiplications? How do I say it? So if I wanted to multiply 7 4 times, by itself 4 times, how would I represent it? 7 to the 4th. So exponents are where multiplication information is held. So tells me how many multiples I want of it. Yes, how many multiplications I want to have. So watch this. This is so cool. And this relates to the whole thing where he picked it up and, colors happened. Yes? I'm sorry if you weren't here yesterday, but we watched a video where they showed us a hidden dimension on a graph, which is trippy. Yes? Okay, all right. Is everybody with me? What will happen? I don't want to go multiply by a full negative 1. I want to multiply by half of a negative 1. So let's draw a fresh number line. If I multiply by a full negative 1, I make a 180-degree turn. If I multiply by half of a negative 1, where do I go? How big of a turn do I make? 90 degrees. Is that cool? That makes sense geometrically, visually. If I multiply, from what we did at first, when I multiply by negative 1, I make a 180-degree turn. Yes? I go from one side of the number line to the other. Or from your perspective, sorry, this one. If I want to multiply by half of a negative 1, I would go halfway.
Oh.
Yeah. So I literally, now watch this. What is half of a negative 1 multiplicatively? It's negative 1 to the 1/2. And what's a 1/2 power? It's a square root. What's the square root do to something? Cuts it in half multiplicatively, right? So that's why I can represent a square root as a 1/2 power. How would I represent a cube root? 1/3 power, because it cuts things in thirds multiplicatively. Exponents are where multiplication information goes. Stop for a minute. Is everybody with me?
Can we have a negative number inside of those?
Ah, here we go. Now, real quick, does everything I said so far make physical geometric sense? If I'm allowed to rotate 180, I have to be allowed to rotate by 90. Do you see how everything we've said so far makes complete geometrical sense? This is me capturing the math of what we just said, but you pointed something really good out. What have you been told about this?
That's not real.
And that's true. Unfortunately, because the way we name things, that's not real. So what do we call it then? Imaginary. The same way that people had trouble with the negative apple. Do you remember that? The anti-apple from the video? Oh, you didn't? You missed it. If I have 2 apples and you take away 3, how many apples do I have? Negative apple. I have the apple black hole. Yes?
Right, yeah.
It sucks in all the apples. Yeah, okay. You guys kind of with me?
Okay.
A little bit? Okay. But this shows you it has a physical interpretation. There it is. It's freaking right there. If I go here, halfway, yes? There it is, right there. It has to exist because we managed to make it through there. We must have gone through something when we rotated. There must be shit out there. I don't know if you guys are with me. So I'm trying to tie the visual with the math because it really helps you realize this is grounded in reality. And again, just to remind you, the whole thing about the apple, we know negative numbers make sense nowadays. Like my bank did when I was in grad school. They knew way too well negative numbers existed. Okay, I'm all right. I survived. Lived a very, I called it, I lived a very plastic life when I was in college. Yeah, a lot of credit cards. So this we balk at, and you should, because of the dumb way we teach it. We always tell you, oh shit, everything goes crappy, when actually it's a real thing. And I know at least one of you guys know what this symbol is for this. I. Because math people are very creative. We're like, what do we call this thing we said is imaginary? First letter is I. Okay, so we call it I. You guys, everybody semi with me? So what's unfortunate for you is you have years of people telling you, you can't take the square root of a negative number. It's terrible, it's terrible, it's terrible. So much bullshit. So much bullshit. Very quickly, does anyone have any aspirations to do any kind of like electrical related stuff, electrical engineering or any kind of engineering or anything? Or no? Okay, I can't remember from your survey if anybody said so. You guys know electricity exists. Do you guys realize that a lot of the ways that we transport electricity wouldn't have been able to be constructed without the idea of complex numbers? So just to push my luck here. You guys know that light travels in waves, right? What's interesting is you have light and you have like electrical field and you have a magnetic field, and they travel at 90-degree angles to each other. Yes. When you determine voltage, the real part of your answer is the electrical part, and the imaginary part of your answer is the magnetic part. And we do the math, and we don't care that we have eyes in there, because when you get to that level, they finally are honest with you and say, oh yeah, we really shouldn't call it imaginary. It's real shit. It actually exists. It's physical. Are you guys at all with me? So right now you're balking because you've been told forever that that doesn't mean anything or you can't do that. No, the answer is it's not real because our stupid naming convention. It is real, it's just the name we apply, it's not that category we call real. Okay, yes.
So,
I'm sorry, I skipped you over.
oh, sorry. Go ahead.
It's okay. My question was about the light, but if it's not,
Go ahead, what's up?
Yeah.
so light transfers like in waves or through matter? Because there was I think an experiment that they did.
Oh, I know, yeah, let's not go into the quantum mechanics.
The,
I could, but let's not. The dual nature of light. You can look at it as a wave, you can look at it as a particle. Let's not go there
because
for right
when
now.
they measure it, sometimes the electron shows and sometimes it does not
So,
show.
I'm talking about voltage actually goes in waves.
Yeah.
Voltage waves.
Voltage, electricity.
When you talk about if it impacts something or other, then you can look at it as a packet. Yes. Okay. So what is its real nature? Both and neither. Have fun.
I,
Yes.
0. Negative 1 to the half, excuse me, is a jump to 0.
No. Okay. Where's 0 on this picture? Here. 0, 0. Yes?
Yeah.
What point is this?
1.
No. 1, 0. Yes? So
Oh,
what point is
okay.
this? 0, I. This is the I axis.
Okay.
Do you remember when, I keep going back to this, remember when he picked it up? What he was doing was he was picking up the function we had, and then he was picking it up into this dimension.
Who's he?
In the video, I'm sorry.
Oh,
I can
never
post it on
mind.
Canvas if I remember, so you can go take a look at it. And by the way, I'm sorry, the video took a while to load because I had to trim the last part because I forgot to turn it off and I didn't want to get a copyright strike. Because I've done that before. Like, I got a copyright. Oh, shit, yeah. Okay. This is, before we got to this, did that make physical sense? If I can rotate 180, I have to be able to rotate 90. But then you start to ask, what is that then if I rotate 90? It's this. So, what if I rotate again by 90? Where should I end up?
Negative 1.
And sure enough, wouldn't that mean square root of negative 1 times square root of negative 1? Because every time I do a 90 degree, that's half of negative 1, correct? So if I do half of negative 1, bam, and another half of negative 1, well, what's the square root of 17 times the square root of 17? 17. So it's the square root of negative 1 times the square root of negative 1. Negative 1. That's the first thing we've ever seen that when you multiply by itself, it comes out negative. That's another reason people don't like complex numbers, because they keep challenging things that math teachers have inappropriately set as fundamental, but they're fundamental for real numbers. They're not fundamental for all numbers. So there are numbers that when you multiply by itself, so here, what we just figured out I squared is? Negative 1. You've never seen that before, because you've never been allowed to see this, which is really silly, to be honest. How we all do. Now listen, how much are we going to do with this? Not a ton. In fact, if you just remember I squared is negative 1, you can get through like 80% of the stuff dealing with complex numbers. That's a huge one. Okay, so every number you have ever seen has been a member of something called the complex numbers. So every number you've seen before today, unless you've seen this before, is a real number, yes? And in the real numbers, there's whole numbers, and there's natural numbers, and there's freaking integers, and there's rational, blah, 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 right? And then sitting next to it are what we unfortunately call imaginary, what the video guy said we should call lateral, which makes sense because where are they? They are to the side of the real axis. And what do you call these muscles here? Lats. So lateral numbers make sense. It's to the side, right? Can we stop for a minute?
For all those meatheads out there that lift.
Okay. Yes, meatheads are included in that. So every number you've ever seen, 7, that is a complex number because complex numbers have a real part and an imaginary part. What is the imaginary part of this? 0. How many I's? How many imaginary numbers did you have when he said the sum number 7? You had no I's, yes? No. So what does a general complex number look like? It looks like real part plus imaginary part. And think about this. Let me see. Do you see all this stuff here that we haven't even talked about? We're not going to talk about it. What about if I turn a quarter of the half of the, oh my God. Every step in here is a collection, it's got a real part and an imaginary part. You guys see that? So that I could write as A plus BI. A plus BI. Yes, sir.
Is that like when you get into like the unit circle? When you start doing stuff like that?
It's the only relationship with the unit circle is the fact that it's a circle, and I talk about the parts, but the unit circle doesn't sit in the imaginary plane. It sits in the XY plane. Yeah. Okay. So let me really make sure you guys understand what you need to focus on. Remind me what's I squared?
Negative 1.
Negative 1. And I is I. So how do I figure out I cubed? Break it up for me. What's I cubed? It's I times I times how many more i's do I need to get I cubed? How many i's do we need? 3. So if I times how many more i's do we need? 2 more. So what's I times I squared?
3i.
As I die slowly. No. What's I? I. What's I squared? Negative 1. So what's I times I squared? Negative I.
Negative I. Yeah.
Yes. All I'm doing, does everybody agree with me? Is everybody cool with these two statements? The first one, you don't even have to know it's imaginary. Let me put to the first power. There we go. I to the first is I. Yes? I squared, we just figured out, is negative 1. If you understand that I captures this, which you now understand is half of a rotation, which you don't have to be able to work with directly. I just want it to be like, okay, it's a real thing. It just has a bad name. Isn't I cubed I times I squared? Is that cool? If you forget for a second what I means, it's just a letter. What is I? What is x times x squared? X to the third. So how can I rewrite I cubed? 1i times 2i's. What is I? What do I be? Let me write first here. I to the first, I second. What's I to the first? I. What's I squared? Negative 1. So what's I cubed? Negative I. And let's see if that works. Watch. This is so cool. Only you think that, Jeff. I know, I'm okay. Is everybody cool with that? If that's I, that must be negative I down there, yes? Alright. If I go one rotation, that is negative 1 to the 1 half of a rotation, right? If I go another one, that would be negative 1. Yes? That is I squared. You guys with me? Every time I do a half rotation, that's I. Another one is I times I is I squared, which is negative 1, yes? If I do another one, I just multiply by I again. What's negative 1 times I? Negative I, that's what we just figured out, yes? Do you see how the computation matches with the rotating? So what happens if I multiply, what would I to the fourth be? Visually, what is it? 1. Let's see if it matches. I squared times I squared. What's I squared?
Negative 1.
What's negative 1 times negative 1? Freaking 1. And then it starts over. So watch this. What's the cyclic nature of negative 1? What's negative 1 to the first power?
Negative 1.
What's negative 1 squared? 1. What's negative 1 cubed? Negative 1. Negative 1 to the fourth? 1. So if you have an even power, all the negatives line up and kill each other. So it's positive. If you have an odd power, pairs of negatives cancel out, and then you have one guy left over alive. That's why negative 1 to an odd power is negative, negative 1 to an even power is positive. So that's a very simple cycle. 1, negative 1, 1, negative. I goes halfway between, so it's going to have 4 steps. It starts at 1. I to the 0 is 1. I to the first is I squared is negative 1, I cubed is negative I, and then I to the fourth is 1 again. So every fourth power, it kind of starts over. So let me ask you this. What's I to the 12th? What's it do every fourth power? It starts over at 1. So what's I to the 12th? 1. Now watch this. I to the 13th has how many extra steps? 4 goes into 13
3 times.
with how many left over?
1.
So it goes back to 1 and then it goes 1 more again. Yes? I'm trying to figure out from your perspective what's right. Is everybody cool with I to the 12th is 1? Because what happens every 4? I go here, I start, blah, blah, blah. Every 4, I go back to 1. So I went again, 8, back to 1. 4 more, back to 1. Yes? So every 4 steps, I to the 4th is 1. I to the 8th is 1. So now watch this. What does that mean? What's I to the 43rd? Watch what you can do. 4 goes into 43. Doesn't matter with how many left. 3. So I to the 43rd is the same thing as I cubed. Do you understand what I just did? If it takes 4 steps to get through its whole cycle, all you have to do is say, divided by 4, what's left? It tells me where I am in the cycle. That's it. With all that said, the most important thing for you to know is I squared. What's I squared?
Negative 1.
Negative 1. Okay, so this is tricky. I feel really bad that we keep this hidden. It just doesn't make sense to me. So watch what this means. What do you guys think? Okay, is everybody cool with this? What kind of number is that?
Complex.
Complex, because it's a combination. In fact, even if that's complex, but it's more specifically imaginary. That's complex, but it's more specifically real. That's just complex, because it's a mixture. What do you think I would do if I try to add, oh shit, Roman numerals might be bad here, Jeff. There we go. What if I try to add two complex numbers? You do exactly what it looks like you would do. What does it look like you would do? What does algebra brain say? Combine like terms. Kick ass. So what do you get?
5 minus I.
Yep. Real parts are 5. Imaginary parts is negative I. Bam! Okay, we just added two complex numbers, and it's easy as shit. What if I put 3 complex? Who cares? I don't care how many complex numbers. It's easy to add them. Yes? Real parts are like terms of real parts. Imaginary parts are like terms of imaginary. That kicks so much ass. Maybe. You guys with me? So what if I multiply instead? What does algebra brain say to do about that? Distribute. I love it. I love that nobody said FOIL them. It brings tears to my eyes. Distribute. Oh wait, do it. You do exactly algebra brain says, but there's one extra step. Let's see if anybody noticed. Just do it like it's a variable. Do it like you do on the algebra channel. By the way, just to remind you guys, at any point, if you don't want to break into what I'm talking about, whatever, you can just get Maria's attention. If I've said something that doesn't make any sense, or anytime I ask you to do something, right? Yeah, hell yeah. She's getting paid for this shit. Ask her some questions.
Actually, I do have a question.
Yeah.
With the, not with this, but with the, if we're dealing in powers of -1.
Yes.
Why is the cycle going this way instead of starting at -1?
Oh. You're right. There is like one thing I didn't put on the top because I didn't want to throw too many. Do I have a? Shit. What really should be at the top is -1 to the 0 power. And what is anything to the 0 power? 1. So before I went anywhere, where am I? Before I turned anywhere,
You're at 1.
you're at 1. So
Okay.
that's why it's -1 to the 0 because I haven't gone anywhere yet.
Why is -1 to the 0 1?
Do you guys remember why? Anything to the 0 is 1? Remind me, what's this? Yes, because 4 cancel, and you're left with 3, so what's the shortcut? 7 minus 4, correct? Alright, what would I put on top so the answer is x to the 0? What power would have to be there? 4. Do you agree? But what is something divided by itself?
1.
Okay, there you go, done.
Okay.
The only number that doesn't work, kind of makes sense, is 0. 0 to the 0 is technically, you ready? This is the technical. 0 to 0 is freaky ass shit. That is the technical way to reference. You actually talk about it in 280 if you get to 280. Actually, we might talk about it in 180. Yeah, we do talk about it a little bit in 180. How are we doing on this?
It's done.
Sorry.
It's done.
It's the same as you as it ever was. 3 times 2, 6. 3 times -5i, -15i. Then this guy gets a turn, right? So it's just repeated distribution is much better than FOIL. 4i times 2. Yeah, I think I heard it. 8i. And then 4i. Now here's where things get. Now don't even worry at first. What is 4i times -5i? Negative 20i
Square.
squared. Now I can put like terms together, yes?
Yes.
What do you get?
7.
Now, what's the one thing we can do because we know I is not a variable? It is a freaky number.
-1 instead of I
Yes, I squared is -1. So I can treat I as if it's a variable, because it is something we don't know. Do you know what the square root of -1 is? No, so we call it I. So we can treat it as a variable, but it is not a variable. It can't be anything it wants to be. It must be square root of -1. And we happen to know for that freaky number, I squared is -1. So I can replace I squared with -1. So then I get,
All the way to
and then I get
26, -7.
Okay. So the first part of that is old news. It's just FOIL, or even better, just repeated distribution. The very last step is just anywhere you see an I squared, make a -1. Cool. Squared, I squared is the most common thing that shows up. That's why I'm not overly concerned if you didn't quite fully get my I cubed and my I to the fourth and my I to the 43rd and all that shit, because I squared is the thing that computationally shows up the most often. Okay, I appreciate some of you guys tolerating me. But can you, anybody, you don't have to make anything up, but is that on some level interesting? Is it hard to say it is because you're like, I have to work with this, so that's got me worried? Is anything we've done with it right now, right there, is it difficult? Because you know how to FOIL. And then you have one extra step. I squared is -1, yes? Now, the most common mistake is I'll have students replace I with -1. Is that true? I is not -1. If it was, we wouldn't have had I. Why do we have to make I up? -1 is cool, right? I is the square root of -1, so don't replace I with shit. Okay. Maybe. Now, I like the idea. I want to cement that complex numbers exist. Where did this show up in algebra is quadratic formula. We haven't officially talked about it yet, but what, do you guys remember quadratic formula? There's part of it's under a square root. That part could be negative, and all that means is you have two complex answers. So remember the parabola that didn't hit the x-axis? If you solve it using quadratic formula, you get complex answers. And the two complex answers, if you want to see them, you got to go to the trippy side. Yes? Where everything's colors. Okay. I like it. Have you guys ever seen something called a fractal? Some fractals are based on graphs of complex valued functions. And remember the colors? And I think I told you guys, the darker the color, the more complex the output. Why do we do that? Let me see if I can get this with me. Do you see up here, this is just the x-axis, correct? This is just the x-axis. And then we have a complex axis off of it, yes? Do you understand that the y-axis also has a complex axis off of it? Do you understand xy plane is how many dimensions? 2. If they each have their own extra dimension, how many dimensions is that?
4.
Holy shit! So, guys, real quick, I'm sorry. Do you all agree that every point in this room is a 3-dimensional point?
Sure.
Look at the floor. If this is the origin right here, this point here could be 1, 2, 1, 3. So x, y, z. Yes? You guys with me? What if I wanted to plot the temperature at every point? That is a 4th dimension. Do you understand what I just said? Think of dimensions as information. How much information do I have right there? 1, 2, 3. If I add one more bit of information, that's 4 dimensions. Not 4 physical dimensions. I'm not, Buckaroo Banzai in the 8th dimension or something. 4 pieces of information. So have you ever seen like a temperature plot that when it's really, really red, white's like really hot? Yes? So I can show a 3-dimensional thing, and if you look at it, the color changes as you move. That would be the 4th dimension. Yes? I don't know what got me talking about. But, oh yeah, that's right. Because that's why we have colors when we graph complex functions. Because I have a whole 4th frickin' dimension to represent somehow. Are you going to have to do that? No. Am I going to bring this up again unless somebody asks me? No, I'm sorry. I won't bring it up again. Yes? Because I don't want to scare you guys. But I do want to share information with you guys. Okay. Alright. The other thing I want to do is just test something out. And then I'm going to let you work on this sheet so I can shut up for a bit. Does anyone know what the square root of 25 is?
5.
Holy shit, why?
Because 5 times itself is 25.
5 times itself is 20. Now watch this. What is 25 divided by 5?
5.
Holy shit, okay. What if I had 27 over 5? Will the answer be a whole number when I divide it? No. But, has anybody ever seen this? This is kind of a silly question, but what number smaller than this does 5 go into?
25.
Holy shit. How much extra stuff does it have?
0.
2. Do you see how, can you do this piece?
Yeah.
What's 25 divided by 5?
5.
5. Can you do this piece?
Yeah.
No, I don't want to. 2 fifths. Especially if it was 2 over 7. Screw that shit. I'm not going to write that forever decimal. Thank you very much. Do you guys remember how to change things to mixed numbers? You had to like long divide and bullshit. Or you could just do that. What number do I wish was up there plus the extra and then break it up? Watch what I'm going to do now. And you're like, yeah, that's what I do, Jack. What if I want to do square root of 50? Why does that not have a nice answer? It's really close. You can give me a decent estimate. What number is that really close to that would have a nice square root answer? 49 would have an answer of 7. So give me a guess for square root of 50.
5 and 2 outs in the.
No. Don't tell me the actual. Hold on to that. 7.08.
Yeah.
You make some shit up and see, right? And then you can put it in a calculator and go, I got close. All right. So you understand that's going to be a little more than 7 because it's a little more than 49 inside. And if it was 49%, okay. But now what you're saying is, just like 27 divided by 5 is some kind of decimal answer, and now I'm wishing I would have made it 7 on the bottom, but it's okay. Just to make it a gross decimal. Square root of 50 is a decimal answer, but do you see how we managed to write 27 divided by 5 as 5 and 2 fifths, not a decimal? I should be able to do the same thing for the same reason. Is there a factor of 50 that I can do the square root of?
25.
Yeah, we just did it. How do I break this up? What's 50? It's 25 times 2. Now, real quick, do you guys see? Is this a whole 50? Is this a whole 50? No. It's how much of a 50? Half of a 50. Do you guys see that? Let me say this again. When I say half of 50, you normally think 25, because you're thinking half additive. In this context, I'm saying half multiplicatively. Yes? How did we factor difference of squares? We cut everything in half, and we all understood it meant multiplicatively, yes? Okay. Half of 50 is half of 25 times half of 2. A whole 50 is a whole 25 times a whole 2. You guys see that? Do you guys remember you can't multiply things unless they have the same root? So root 25 times root 2, I can multiply. Root 25 times 2, can't do shit. Well, I can make 25 5 and blah, blah, blah. Okay. So just like over here, I broke it up into a part I could do and a part I could not do. And then I did the part I could, and you're not going to believe this. I didn't do the part I couldn't. So here, what's the square root of 25?
5.
Holy shit. What's the square root of 2?
Square root of 2.
I don't know. There. So that is called simplifying the radical. You broke it down to lowest terms in a way, if you want to make it analogous to something students normally hate, so maybe that's a bad idea. Make it analogous to fractions, Jeff. That'll go over big. Okay, so I'm going to finally shut up. No, it's fine. And I might not have printed enough of these out, because I might have forgotten to print more. Oh, here we go. I did. Look at me go. Oh, man.
I was just kidding.
Oh, you were? Okay. I was going to go assume a fetal position in the corner. Try. Oh, got everybody? Got one? Yes. So, so this stuff is trippy, but it's a more complete picture of math. And the nice thing is, I mean, I've teased some other stuff, but I'm trying to make it really clear what you need to worry about. You don't need to worry about everything I said tonight. I went a little off the rails with some of what I said. It's just I squared, right? It's just how do you combine things. This one is just how do you break things up. So let's start at the very beginning. This one is the one we did. You break it up into a square number and whatever else. You do the part you can, you leave the part you can't. This one, I'm going to do it the way most of us did. Square root of 9 times square root of 8, 3 square root of 8. But let me ask you this. If I ask somebody to reduce a fraction like this, 12 over what, Jeff? 48. And they say, okay, it's 6 over 24. Are they done?
No.
Couldn't they just do one more reducing? Okay. So this one, I sometimes call this reducing the radical because it does feel like reducing a fraction. It's the same idea. Did you break this down in the biggest number way you could have? No. Did you have to know ahead? No. Can you break square root of 8 up into a square rootable number times something else? Yes. 3, square root of 4, square root of 2. What's the square root of 4?
2.
That's crazy. 3 times 2. Okay. And then you can go, oh shit, 72 is 36 times 2. Square root of 36 is 6. Square root of 2 is square root of 2. I could have gotten there in one step. Who cares?
Tracking.
Okay. This one is trippy because it feels like you should be able to do more with it, but you can't. This is 4 times 30. Now, real quick, how do I know? It feels like 30 should be able to go, right? But what's in 30? 2 times 15. So it's got a 2, it's got 1 3, and it's got 1 5. Yes? What does the square root need? How many of something does it need inside of it for it to be doable?
2.
2. Square root of 49 works because it's got 2 7s. Square root of 30 ain't got 2 anything. It's got 1 2, 1 3, 1 5. So he doesn't go anywhere. Yes? Okay, I like it. Maybe. Square root of 80 had the same problem as the square root of 72. I think most of you guys did. Actually, I can't remember what most of you guys did.
20 and 4.
Oh, okay. 420.
I like that.
Earlier, I got 419 as an answer, and I said, "Oh, off by 1," and nobody reacted. So,
No way.
what? But again, same idea here, right?
Yes.
What number goes into 20?
4 and 5.
Yeah, 4 times 5. Square root of 4 is 2 times 2 is 4. So you could have broken up 80 as 16 times 5, but that's a freaky factorization. Who cares that he didn't know it? Yes?
Yeah.
What about the square root of 33?
Just go ahead and put a box around
Do what now?
it.
Oh, you want to have it, okay. Have it be very warm inside of a box, okay. What about number 5? What about square root of 33? What can I do with that? Not a damn thing. It's sort of like if I said, reduce 4 over 9. You should go, I'm done. Right? So that one, you can just circle the damn thing.
Yep.
I'm done, Jeff. I was done before you gave it to me. All right.
That was sweet as candy.
This one? How sweet was it, you said?
It was sweet as candy. Yeah, I don't know.
Yeah, today's been weird. This one, Jeff? This one's sweet as candy. I can tell you honestly, nobody's ever said that about this one. So I like that a lot of you guys picked out that this is divisible by 9. So that you could break it up as 9 times 81. Yes. And what's the square root of 9? 3. What's the square root of 81?
9.
And that is 27. Now that came out to a whole number, and you can check it in your calculator. Do 27 squared. Sure enough, you get 729. A fact that we certainly don't have committed to memory because we're not crazy. I do, but I am crazy, so that's fine. Just that one. It's like I have the division by 7. Not memorized, but I have a way to calculate it. Just because it happens a lot in probability. It's neat. Well, Jeff, that sounds, you should put that on your resume. Okay. So what about the back here? I want you to realize something about this. Okay, the first level of realization I want you to make about this is you can break it up just like we were doing. What's this? See that? What's the square root of 4? What's the square root of -1? But now you realize, what's the square root of 49? So what's the square root of -49? 7i. So if it's the negative of something you could take a square root of, you just throw an I on it. Which is a very strange phrase outside of this class. Yes?
Say that again?
Throw an I on it.
Ah,
Ah.
that's fire.
That's
I
fire.
think you came prepped in a different way. What about part B? Can I do the same kind of idea?
Yeah.
I break up like I did just a second ago, but then what can I do with this guy? No way. So this would be rad 9, rad 2, rad negative 1. What's rad 9? 3. What's rad 2? Rad 2. And what's square root of negative 1? Now, if I put it here, do you see how it sort of kind of could migrate inside? And that, I need you to understand how freaky that is. Do you all agree that I is freaky? I do be freaky. What about the square root of I? Do you want to think about that?
No.
So what we do, to be careful, is if I ever have a piece that's an I just put it in front. We normally end with the radical so nothing accidentally gets sucked into the back end of the radical, which again is a phrase that only makes sense in math. You don't want to have odd things get sucked into your back end. What about part C? The mistake students make is they'll go negative 9 to negative 4 is 36, so square root of 36 is 6, and that's wrong. That is very wrong. What is the square root of negative 9? 3i. What's the square root of negative 4? 2i. What's 3i times 2i? 6i squared, and what's I squared?
6 times negative 1.
Negative 1, so negative 6. There you go.
Awesome sauce.
On top of awesome fries.
Ah.
So what about, so then 2a and 2b, I'm hoping those are very straightforward. Those are almost just algebra, especially 2a. Oh, I get time. This is crazy. So what do we get here? Real part, 5, and the imaginary part, plus 2i. So go. And then this one, just to cut to the chase, 3 times 2, 3 times negative 3i. And then this will be minus 15i squared. My poor little I dude. All right. 6 plus I minus 15i squared. But what's I squared? Negative 1. So that just changes signs, and then I get 21 plus I. Now, real quick, I'm not going to show you right now because I'm evil. But on your TI calculator, you can actually have it do complex numbers. So look it up, kids. All right.
I don't need that.
If you have a TI calculator.
Carefully figure it out.
Real quick, what's I to the 8/3? How do I do that? Every 4 steps, it goes back to 1. So if you just divide by 4, you take all those rotations out of the way, right? If I rotated 9.5 times, you could just go, screw the freaking 9. Just you would have half. There, Jeff. So I can take out all those rotations. If I divide by 4, what's the remainder? Tree. So you make like a tree. What's I cubed? Negative I. Okay. I like it. All right. Kick ass. Okay, so the last thing for today. By the way, I was wondering if I wanted to say something, but I've been using this book as kind of like a guide as to pacing and so forth. And then I realized that is really silly. So I'm going to use the textbook, and then I'm going to pull in stuff as we go through the textbook. From my perspective, it's going to help me. And from your perspective, it's going to help you with the homework, because we're going to march through it in order. That's much better.
Yes, I agree.
And from my perspective, I'm going to feel like I'm a little more grounded instead of this thing I'm not used to. Yes, okay. Grounded in a good way. So, we're going to get into this. Average rate of change. Oh, yeah. So, where's Maria? She's gone. Okay. So, if you go, how many guys take road trips? Anybody like a road trip? Yeah? Do you remember when you were small, did you ever take like family trips? I'm sorry. I didn't mean to get in it. I'm sorry, I didn't mean to bring that up. Road trips, I remember road trips were horrific for me until we got somewhere and then I'd get out of the car and be happy because my stepfather was a very miserable person. But I love road trips, right? So I don't want to bring up. When you take a road trip, my stepfather was we got to be there this time. So if you needed to pee, he would literally just crack the door open. If you're not quite done peeing, hang yourself out the window, we're going, right? That was really fun. If you make a bunch of stops, your average speed will be lower than any speed you travel at. Does that make sense?
Yes.
Okay, so if I want to figure out my average speed, and what is speed? What is speed?
Like how far.
What does it measure?
How far something goes in
Distance or amount of time.
Yeah, how far something goes over a matter of time. Yes? So it's an average rate of change of position. So if I'm here and I change my position by 5 meters in 3 seconds, I've gotten 5/3 meter per second. Are you guys all with me? And I'm sorry to use meters for us Americans. Okay, I know. Canadians, you give them an inch and they'll take 2.54 centimeters. Still left from someone. So, if I want to know the average rate of change when my motion is straight, so like I start here and then I leave home and then I'm like, oh shit, I forgot something. So then I got to go back home and then I leave again and then I want to know what's my average rate of change from here to there. Do you see how it's going to be pretty small? Because I had to go back home. So the actual amount of distance I got from my home after that much time is very little because I had to go back. Right? You guys with me? So what the hell? How do I figure out? So let's put some numbers here. Let's say this is 10 miles away from home. This is 20 miles away from home. And this is beautiful. 15 miles away from home. And let's say this is... what kind of scale do I want to use? Screw it. This is... we left at a really bad time. This is... we left at 1 hour past 12. Oh, I can make it nice. Okay, let me do this. And this is 3 hours past 12. So like 1 o'clock, 3 o'clock. So how much time was on the road? 2 hours. So how would I find the average rate of change, which would in this case be the speed, the velocity, right? How much did my position, my distance from home change? Yeah, well, it changed by 5, right? Because how far did I end up? 15 minus 10. So I changed that by 5. So the average rate of change. And I could even, this doesn't matter if I call it distance from home or whatever, this is a function, and these are the inputs. In the specific example I'm giving you, x is time, f of x is distance from home, yes? So the average rate of change of this function is going to be how much did my y's change divided by how much did my x's change. Does anyone know what that is? Slope. So this would be 15 minus 10, that's how far I got away from home, divided by 3 minus 1, that's how long it took me to do so. So I get 5 halves, which is?
5 half.
Huh? 2.5. Did I give us any units? What did I say up here? I didn't give us any units. Let's say these are miles and these are hours. So this would be 2.5 miles per hour.
Jesus.
Go team.
That's super cool. You're gonna smell space there.
Now real quick, do you understand I was going much quicker?
Yes.
The entire time I was going much quicker. The average rate of change factored in the idea. In fact, do you guys know what was my velocity here? Negative. Because I was going back home. I wasn't racking up distance from home. I was losing distance from home. You guys with me? So velocity can be negative. It just means which direction am I going. So if I average positives and negatives, it makes sense that I got a pretty damn small number. Okay, cool. So average rate of change of something is just another name for slope. Now what's really weird is when you look at this picture, does the idea of slope make sense? Because isn't this a big curve? Yes? But what we just did was we figured out the slope of that straight line connection. So if I get the average speed, that is, if I had gone from there to there directly over this much time, that's how fast I would have been going. It just takes all the bumpiness out. Does that make sense?
Yes.
When you get into calculus, average rate of change is huge. That's basically the entire first half of calculus is devoted to studying that. And you see it's related to slope, but here's what calculus does. If I have a line, can I figure out what the slope is? Does the slope ever change? Does the slope change for this thing? Can you imagine if I would have put a different point, like over here, would the average rate of change have changed? Yes. So what's happening as I move along this? Isn't my slope changing constantly? So that's what calculus does. It gives us tools so we can find a slope of something that isn't straight. That's constantly turning. Yes? Do you all agree that the slope at this x value is different than the slope at this x value? So if I got the slope of this function, wouldn't it be dependent on the x value? So if I'm x equals 1.5, maybe the slope is 3, and if I'm at x equal to 2.5, maybe the slope is -1 or something. Do you guys see that? Everything I just discussed in the last minute or so is calculus, so it's not going to be anything worried about this. But I always want to point you to what we're learning is immediately going to be applicable in calculus. This is going to be like chapter 2. It's going to be devoted to this idea. Most of the sections in chapter 2 in calculus. So, we're not in calculus, so let's talk about what we have to worry about. Can anybody tell me, like here's a nicer graph, right? Because a computer made it, so I'm not going to feel too bad about that. Can you see how this is obviously decreasing? Okay. And I think we talked about this already. Didn't I already have a problem where I told you find where it's increasing, decreasing? Okay, you did that. So I already talked about some of this. Oh, well there you go. We'll be studying further in the book. Okay. So let's look at this, and then, oh good, we got time. Okay. So, by the way, in case you're a little confused, we are in Module 4. Because our first bit on the homework is Module 1, Module 4, Module 5. Yes? So part of this is asking you questions we've already done. What is important to note about this graph? What's happening at the ends? It keeps going in that direction forever. Yes? So it has to show me all the turns. If they put an arrow, I understand that means it keeps going in this fashion. So can anyone tell me what the domain is? Yes. All real numbers, yes. So I want us to get more used to interval notation because it's going to be, again, most calc teachers are going to want you to talk in interval notation. So negative infinity to infinity. What other range?
Same thing.
Same thing, because it goes all the way down, goes all the way up, negative infinity. Now, here's a word that we haven't talked yet, and I want to see what you think about it. How many relative maximums are there? So, yeah. If I say absolute maximum, this doesn't have one. Because does it ever actually get to a highest point? No. But if I say relative maximum, yeah. It's like you could be on a bumpy plane, and you can go up a little hill. That's a relative maximum position. Yes? And then you see a bigger hill. You're like, screw that. Let me go. Oh, well, now I'm at a higher. I'm like, what's bigger hill? So how many relative maximums are there? Where is the smaller one?
-4.
Good. -4. Where is x, right? So let's see what they ask here. Oh, this just says what is the relative maximum. So here you can give me a point. If they would have said where is the relative maximum, it would be occurs at x equal -4. What is the relative maximum? What is one of the relative maximums? -4. You all with me? So this could be a graph of profit. And maybe 0 is like where we made a change. So like 4 years before we made the change, we were at a max profit, which was when we were losing negative $1,000 or whatever. You with me? And then we make, well, if this is where we made a change, it's kind of bad for us, but I want you guys gonna with me. We made a change, we're like, oh shit, and then we undid it and we're like, oh good. That could represent profit. And of course, if you have profit and you know ahead of time, you can have predictions about what's going to happen with your profit based on how much you set the cost of something at, then you have a target. So the people that sit there, my friend Sean, when he was alive, his job was financial analyst. And he made 6 figures. He had 5 kids. So it went on. But his job was to study data and tell the company, set the price point here. This wasn't his whole job, but it was a big part of his job. Are you with me? So he just had to keep on top of all these different data points, and then the model wasn't perfect. So you're always reaching for this thing you never got. You with me? I would never do that job. I'm sorry. It would be something I wouldn't really believe in, helping other people get more money from them. But Sean, I don't believe. He had a lot of people to feed, so I'm like, do what you can. So relative maximums. One we got was -4, -1. What's the other relative maximum?
0 to 3.
Yeah. 0, and of course at 0, and the max is 3 there. I like it. And of course, same thing for min. How many relative means? Sure, Jeff. Relative mins. 2. What are they?
-2.
Yeah, it occurs at -2, and the output was -3. The other one occurs at 3, and the output was 0. Kick ass. You guys all with me? No? What happened? What's the matter? Tell me. I'm sorry, I'm putting you on the spot.
No, it's just relative maximum shouldn't be like the biggest point, or
Relative to things around it. So where are the hilltops? Isn't this a hilltop? Right here?
Yeah.
Relative to things around it, isn't that the maximum?
yeah.
Can't you be in your neighborhood the one who does something the best? So you would be a relatively the best person, right? If I expand that to the state, am I necessarily the best person? No, there's probably going to be somebody else who's even better than me, right? But you have all these relative maximums. Does it make sense?
Yeah.
So relative to values around it, this is the highest point.
Even higher than 0 to 3?
No. Relative, another name for relative, and the one I like better is local. That actually is a better, and to be honest, at least when I teach calculus, I use the word local here. Local min and max makes more sense. Locally, what's a maximum? That's a maximum locally. If I only go out so far, and to be honest, you guys ready for this? If I go a little bit of distance out, we call the mathematical term for that is a neighborhood. So I lived my example, I didn't do this on purpose, is the math. So if I go in a neighborhood, that's the highest point. In a neighborhood, that's the lowest point. That's a local min. Local max because locally it's the highest. Local min because locally it's the lowest. Is there an absolute max? No. Is there an absolute min? No. But if this kept going up, that would be the absolute min, yeah? Okay. We stop for a minute. Not terribly difficult, especially when you realize what that word means. It's not the biggest. It's just locally the biggest. It won the local pageant, right? Okay. And then these we've done before, yes? Can somebody just tell me the first place that's increasing? Let's see if you guys are cool, because what's this do? So where's it increasing? From what? Negative infinity up to negative who? Negative 4. So it starts at negative infinity, and it keeps increasing to negative 4. And then, of course, it increases from negative 2 up to 0. And then you can keep going. Is that cool? Yes?
Do we always talk about maxes and mins and increasing and decreasing in terms of the x-axis, never in the y-axis?
Where is X? What is Y? So when I say where does a max occur? At X equal whatever. If I say what is the max value? That's the output.
Makes sense.
And this one was just said what's the local max. So I'm like, we could just put the point there because it didn't say where or what. It just said local max.
But, yeah, so when you're asking for the increasing and decreasing, what it's really asking is
On what interval of X does that occur?
for what inputs.
Where is it increasing is X-axis. Yeah.
Okay.
Decreasing the same way. So, I mean, you guys get the idea pretty well? I mean, this one has how many relative maxes? Yeah, 1. How many relative mins? 2. Does it have any absolute min?
Yes.
Yes, good. It's a tie. The absolute min value is -5, and it occurs at -4 and 2. It's like you have a big competition in this lake, this guy caught 12 fish, and in this lake, this guy caught 12 fish. They tied, right? So you're going to have ties. That's a relatively straightforward set of ideas, I hope. Okay, if not, we can go over some more. So the last thing I want to talk about is, well, let's see, I didn't really come with enough. That's right. I'll have to do that next time. That's okay. Yeah, I think next time at the beginning of class, we'll focus on graphing stuff in the calculator. I just said the magic phrase, which is next time. I just want to point out where it actually starts talking about average rate of change is the slope. Yes? And this is where it starts to overlap a lot with calculus. So I'll tell you this. Let's do this. Don't get used to this. We'll officially end class now. But if anybody wants to hang out for a bit, especially the people, anybody, but because a lot of you guys just come straight here, you don't have time for office hours. If you have any questions from homework or whatever, or just general questions, ask. If you don't have a damn thing to ask me, you're free to go. And I'm not going to take it bad if you leave, it's fine. But if you stay, what do you got? Yes.
Just a book, so we can study for tomorrow.
You have a what now?
We need the book so we can do the homework and study for tomorrow's quiz.
Oh, that's right.
Just send your email.
You send me an email and you send me an email, so I'll send you the link.
Okay.
Yeah. I'm not going to send the PDF because it's huge.
That's
Um,
Would you consider possibly sending it to us right now so we could use the rest of our time to start?
Just do it.
I'll think about it.
Okay.
Yes, okay. While I'm doing this, does anyone else have a topic of discussion? Did you say something about doing taxes? What?
You said you asked if we had a topic of conversation.
I'm verklempt.
If you need help with your taxes, I can help you. I just did mine.
Awesome.
2 years of it.
Smart email. Oh wait, did you send me over to Canvas? Or just regular email?
Jeff.
Okay,
might be
regular
your-
email.
Yeah.
Oh, that's where I was, Jim. Me, I'm so smart. Okay. I agree. Okay,
Send
let's
it to
see.
your Jeff.
Let me do this.
I sent it
Oh,
to
there
your
you are.
GCCCD email.
Alright, so I don't have everything, but right now I can send you the book information. And then if you remind me, I can send you later other materials.
Okay. Yeah, I just wanted enough so I can do the homework.
I think we have to September 3.
Well, yeah, but there's
Yeah.
Oh, no, so there you are, okay. Reply, shebang. Okay, I sent it to you.
Thank you.
That's a link to the website, and then you can click on the view online or download PDF.
I don't know where, I just got an email.
The power of the internet.
Thank you so much.
Because there's not a lot of people here right now, so the response not overloaded.